last section is on solving radical equations. We'll start with this one, the cube root of 2x plus 7 equals 3. What that really means is 2x plus 7 to the 1/3 power equals 3. So the first thing you have to do is the opposite of cube root, that is to take it to the 3rd power. Take both sides to the 3rd power. You're left with 2x plus 7 equals 27. Finish that off to get 2x equals 20, x equals 10. Next type of problems like this, with some weird exponent. So do everything besides that first. So you add the 1 to the right side to get x plus 2 to the 3/4 equals 8. Then, if you want to get rid of that 3/4 power, you multiply times the opposite. You take it to the 4/3 power. That cancels out to 1, so you're just left with x plus 2. You also have to multiply this 8 to the 4/3 power. So you have x plus 2 equals 8 to the 4/3 power. I'm going to go ahead and plug that in. So 8 to the 4/3, make sure it's in parentheses, equals 16. X is equal to 14. This next type of problem is pretty challenging. The problem is that there's x over here. There's also x over here underneath the radical sign. When this happens, you have to start by squaring both sides. So I'll square this, and I'll square this. This is just to get rid of that radical sign. Remember, that's to the 1/2 power, so taking it to a power of 2 reduces it to nothing, or 1. So we have, this is left as 7x plus 15. And x plus 1 squared is x squared. Remember, that's x plus 1 times x plus 1, so x squared plus 2x plus 1. We'll try to set it equal to 0. So x squared minus 5x minus 14 equals 0. I subtracted the 7x over. I subtracted the 15. We have x squared minus 5x minus 14 equals 0. We're going to factor that or graph it and calculate the zeros. I'm just going to factor it because it's faster. So x minus 7 times x plus 2 equals 0. So that means the zeros are at 7 and negative 2. However, something you need to be aware of. When you have x on both sides of the equation like this, and you take them both to a power of 2, like we just did, sometimes you get answers that aren't correct. So we actually have to check if both those answers are correct. We have to plug them back into the equation. So you have to check each one to make sure. I'll also show you how to do this with your calculator, but I want to make sure you know how to do it by hand first. Okay, our answers were 7 and negative 2. We got to check both of them out. So let's try 7 first. So 7 plus 1 equals square root of 7 times 7, 49, plus 15. That's 8 equals the square root of 64. 8 equals 8. That means that 7 is an answer. Now let's check the other one. So we have negative 2 plus 1 is negative 1 equals 7 times negative 2 is negative 14 plus 15. So we have negative 1 equals the square root of negative 1, or negative 1 equals I. That's not true. Negative 1 does not equal I. So that is not an answer. So for this one, only 7 is an answer. Even though we found 2 answers, only one of them is true. Now if you want to check this in your calculator, what you need to do is this. Treat each of those sides as a different equation. Let me find a highlighter here. So treat this as one equation. So x plus 1. And treat the other side as a separate equation. Square root of 7x plus 15. X plus 15. Graph it. And what we're looking for is the place where they cross. You can see over here at negative 2 they actually do not cross. And at positive 7 they intersect. It's kind of hard to see, but let's go ahead and calculate the intersect. Second, calculate intersect. First curve is the first line, second curve is the second line, doesn't matter where on the line, just that it's there. Guess, and it says the answer is 7. So that's definitely a shortcut to finding the correct answer. I showed you the algebraic method, how to do it by hand, and also how to do it with the calculator. We have one more type to do, and that's where we have radical on both sides of the equation. When we have a radical on both sides of the equation, like this one, we're going to square both sides to get rid of those radicals. Once again, if we're squaring x's, we may be introducing solutions that aren't real, so we're going to have to check that later. But let's go ahead and square this. That's x square root of x plus 2 plus 1 times square root of x plus 2 plus 1 equals the square root of 3 by radical 3 minus x is just 3 minus x because that's 1/2 power to the second power, gets rid of it. But we actually have to multiply that out, so square root of x plus 2 times square root of x plus 2 is just x plus 2. Those radicals are to the 1/2 power, so 1/2 plus 1/2 gets rid of it. This times 1, and the same thing times 1, so plus 2 square root of x plus 2, and then 1 times 1 is just 1, equals 3 minus x. Okay. Now we're just going to combine what we can and try to get x on one side. So over here we have x plus 3 plus 2 radical x plus 2 plus 3 minus x. We need to leave this radical on this side, but we need to get this other x away from it. So the 3 and the minus 3, or the 3 and the 3, those are going to cancel out. And we're going to subtract this x over to the other side. So we have 2 radical x plus 2 equals negative 2x. Then we're going to divide by 2 to get radical x plus 2 equals negative x. Now we have to square this and square this. We get x plus 2 equals x squared. Subtract this stuff over. 0 equals x squared minus x plus 2. Now we have to factor to x minus 2, x plus 1. Our answers are positive 2 and negative 1, but of course we have to check, make sure those make sense. So you have two choices. You can take them and plug them into this original equation to check if they make sense, like I did the last one, or you can just graph those two original equations. Let's go ahead and do that. So the square root of x plus 2 plus 1, and the second equation is the square root of 3 minus x. Let's graph them and calculate the intersect. Looks like there's just one intersect. First curve, okay. Second curve, guess. Intersection is x equals negative 1. That means that the only answer here is actually negative 1.